All right, for number 10, a no calculator problem. We need to be able to graph vertical and horizontal lines and know that exponentials look like this green curve, and when x is 0, it's equal to 1, it crosses the y-axis at 1. This is the region. Next step, make your representative rectangle, man. Make that representative rectangle so we know that the width of the rectangle is dx, and the height of the rectangle is the y value minus this y value. The y value of the green curve minus the y value of the red curve. Remember, if you were 18 and I'm 55, the distance between us is 55 minus 18, or 37. So the height of the rectangle is the green y value minus the red y value. Area of that rectangle is length times width. So we're going to accumulate all these rectangles as they get infinitely skinny. The area of this region is accumulating rectangles as x goes from 0 to 1. The width of the rectangles is dx, and the height of the rectangles is the green y value minus the red y value. This is the area of the region in question. Let's go ahead and do that without a calculator. Pretty simple anti-differentiation. And now, using the first fundamental theorem of calculus, we'll evaluate the antiderivative of 1 and at 0 and subtract the 2. So we have e squared over 2 minus 1 minus 1/2 e to the 0, which is just 1/2 times 1, minus 0. All right, we're pretty much done here. It doesn't match any of the answer choices yet, but if we get common denominators, it will. So we have e squared over 2 minus 1, which is 2 over 2, and then minus 1 over 2. So we have e squared minus 2 minus 1 all over 2, or the answer e squared minus 3 over 2.